Video I'm going to show you how to work out the rule that describes, in this case, how many matchsticks make up each pattern, and we in particular want to find how many matchsticks would make up any pattern, and then use that to find how many matchsticks in the 11th and 55th, or the 11th pattern, and how many matchsticks, or what pattern has 55 matchsticks in it. So here we have pattern 1 with 3 matchsticks, pattern 2 with 5 matchsticks, pattern 3 with 7, and pattern 4 with 9. And the first thing we're going to do is create a difference table. So I'm going over here. So I need to be able to create a difference table for this, or a table of differences. And this table of differences really allows me to do some calculations. So I'm going to put this table in. In the first column we put pattern number, and that's going to act as our X variable. In this column here we put number of matchsticks, and that's going to act as our Y variable. Then we're going to do the first difference, which I'm going to call M, and you'll see later in the term why that is so. I'm going to put here M times X, and here I'm going to put plus C. So first of all I go ahead and just put in the pattern numbers. So I have 4 pattern numbers, and there were 3 matchsticks in the first one, 5 in the second one, 7 in the third one, and 9, and we don't really know how many are in there. Now the first difference is just the difference between 5 and 3, so the Y values as we go down. So I'm going to go 5 minus 3, which equals 2. I'm going to go 7 minus 5, which also equals 2. And I'm going to go 9 minus 7, which equals 2. So the first difference here in all of these patterns is 2. And the fact that the first difference is constant tells me that I've got a linear pattern. So if the first difference is the same, 2, 2, 2, then you know you've got a linear pattern which could be plotted on a graph as a straight line. Now the next step is to take this constant value and multiply the X value by it. So I'm going to go 2 times 1, and that equals 2. 2 times 2 equals 4. 2 times 3 equals 6, and 2 times 4 equals 8. Now to get C, you just have to look at this and see how much you have to add to it to get each of the Y values. And in this case we have to add 1. So 2 plus 1 equals 3. 4 plus 1 equals 5. 6 plus 1 equals 7. And 8 plus 1 equals 9. So my multiplier is going to be 2, and the constant that I add on is going to be 1. And that really basically gives me my rule. I can even start. This would be 2 times 5 equals 10, and so there would be 10 plus 1 equals 11 matchsticks in the fifth. This means now that I'm ready to write the rule. So I'm going to So the rule is, because this is a linear pattern, it's going to be y equals m times x plus c. So in this case, it's going to be y, the number of matchsticks, is going to equal 2 times x plus 1. And that describes every one of these. If I typed in here y equals 2x plus 1 and did the calculations here, we would see that that is true. So 2 times 1 plus 1 equals 3, and so on all the way down. So my rule is made up of m and c. So m is the first difference, and c is how much do I have to add or subtract. And the final piece here is once I've got my rule, I want to do the calculation. So we wanted to know how many matchsticks made up the 11th pattern. So y equals 2 times x plus 1. So y equals 2 times 11 plus 1. So y, the number of matchsticks, equals 22 plus 1 equals 23. So we would need 23 matchsticks to make the 11th pattern. If I knew that there were 55 matchsticks in the pattern, what pattern would it be? Then 55 would equal 2 times x plus 1, and we'd use our algebra to solve this. So first of all, I'd subtract 1 from both sides, so 55 minus 1 equals 2 times x plus 1 minus 1. 54 equals 2x. And now I divide both sides by 2. So 54 divided by 2 has to equal 2x divided by 2. So 17 equals x. So the 17th pattern has 55 matchsticks in it. And we can apply the same now to this situation here. This time we've got a sequence. So term 1 had 4, term 2 7, term 3 10, and so on. And we want to find what rule would describe any value for any term. So again, we go ahead and just make a table of differences. So I'm just going to move that. So I'm going to put my table of differences in here. So I'm going to and we're going to do the same procedure as we did before. This time though, in the first column, I'm going to have term, and that's going to be my x value. I'm going to have value, which will be the y, and then I'm going to have first difference, which is going to be m, I'm going to have m times x, then I'm going to have plus c. So here we've got 1, 2, 3, 4. I've got a fifth term there. I could put that in. The values would be 4, 7, 10, and 13. Now I'm going to find the first difference, so that would be 7 minus 4, which equals 3. 10 minus 7 equals 3, and 13 minus 10 equals 3. So again, the first difference is constant. This means this is a straight line or a linear pattern, and that's my m value. That's my multiplier. So now I'm going to go 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. And 3 times 4 equals 12. And now you can see I have to add 1 again to each of these to get them back to the y value. So c is going to be 1. So 3 plus 1 equals 4. 6 plus 1 equals 7. 9 plus 1 equals 10. And 12 plus 1 equals 13. So my rule is going to be y equals 3x plus 1. And if I multiply each of those there, I'll just do the first one. So we're going to have 3 times 1 plus 1 equals 4, and so on. So my rule is found, and now I can use it to calculate the things that I want to calculate. So I'll just put this in. So if the rule is y equals 3x plus 1, then I can go ahead and substitute 11 in for x. So y equals 3 times 11 plus 1. And that would be 33 plus 1, which would be 34. So y will equal 33 plus 1 equals 34. So the value of the 11th term in this sequence is 34. And if I knew that there was the value of a term was say 66, we could or 67, let's say it's 67, so 67 equals 3 times x plus 1. So again, I'm going to subtract 1 from both sides, so that gives me 66 equals 3x. Then I'm going to divide both sides by 3. Which means that 22 equals x. So it's the 22nd pattern that has a value of 67. And that's how you calculate the rule using a table of differences.